Hello everyone, welcome to Learn Medicine Easily YouTube channel. If you did not subscribe our YouTube channel yet, so please subscribe our YouTube channel and also push the bell button to receive our videos notification first, and don't forget to share our channel with your friends. So in our previous lecture we talked about three part of ECG. Today we will explain the ECG part 4, that what and what we will study in this part. I will explain you these things. So please don't forget to subscribe and watch our video up to end. You will know a lot of things. I hope you will learn some things. So upcoming things in this part or in this video, what you will learn. So basically or mainly I will explain these 4 things. So what is electrocardiography, and what is electrocardiogram, and also electrocardiograph, and also what is electrocardiogram in normal ECG waves. So how a normal ECGs look like, I will explain these things. So first of all, you should know that electrocardiography. What is electrocardiography? As I told you in the previous lecture, if this is the heart, with it is 4 chamber, the left atrium, and this is the right atrium. This is the left ventricle, and the right ventricle, and the right atrium. As you know that the heart has a special activity which is started from its anode located in the superior lateral part of the right atrium. When it produces electrical impulses, it spread to the atrium, then it came to the ventricle. And recording of this electrical activity is called electrocardiography or ECG. And the process, easily you can say, the process of recording of these electrical activity is called ECG, or the process of taking ECG is called electrocardiography. And then another thing, electrocardiograph. Electrocardiograph is the machine of ECG. The machine which record ECG from the patient is called electrocardiography. Only one. Why is the difference between electrocardiography and electrocardiograph? You should know that if someone asks what is electrocardiograph and what is electrocardiography, you can easily say that electrocardiograph is the machine of ECG and the electrocardiography is the process of ECG taking of the patient. And then another thing, and very important thing, electrocardiogram. That what is electrocardiogram? Electrocardiogram is a special type of paper used for ECG recording. So you can see in this paper 2 type of line. It is completely lined paper. It has one small square in it and also large square. Actually it has 2 type of line: horizontal vertical lines, and horizontal lines. It has vertical and horizontal lines, and also it has thin lines like this. This is a thin line. It has thin lines, and also it has thick lines, thin and thick lines. And this one is thick line. It has 2 type of line. So when 2 thin lines are crossing each other like this, one and another thick line, so they make one small square. And when 2 thick are crossing each other like this, one is here and another is here, they make a large square which consists of 5, 1, 2, 3, 4, 5 small square. You can easily say these things in a very simple way, that electrocardiograph consists 2 type of lines, one thin line and one thick line. When 2 thin line are crossing each other, they make small square, and when 2 thick line are crossing each other, they make one large square which consists 5 small square. And don't forget that the y-axis or the vertical axis, so this is y-axis, you can easily say vertical axis or y-axis, and this is horizontal axis. The horizontal axis or x-axis. So the y-axis is for voltage. So in a vertical way, so this paper shows the voltage, and in the horizontal way or in the x-axis, this paper show the time. And 2 things you should remember is is 1 small square time and voltage. So 1 small square is equal to 0.04 second. So this is the time of crossing of 1 small square from ECG patient ECG machine. We roll this paper in the ECG, and in a special acceleration it is coming out from ECG machine. From here it is coming out like this, and it has a constant acceleration, and that constant acceleration is 25 millimeter per second. Thus that constant acceleration is 25 millimeter per second. It means it takes 0.04 second to come out one small square from ECG machine, and it takes 0.2 second to come out one large square or 5 small square from ECG machine. It means that this small square takes 0.04 second to cross from ECG machine needle. It has a needle which point the ECG, and this paper is crossing in a constant acceleration of 25 millimeter per second. So if we do these taking of ECG, so 1 small square will come out from ECG machine in 0.04 second. And also one height of 1 small square is 0.1 millivolt. So voltage of 1 small, easily you can say that voltage of 1 small square is 0.1 millivolt, which is calculating in the vertical axis, and the time of 1 small square is 0.04 second, which is calculating in the horizontal axis. And then we come to the very basic thing and the very important thing of ECG, how a normal ECG look like. So you can easily see in this picture normal range for ECG interval. I will explain these things, that why it is like this and why these are like this. So now you just trust me that ECG have these waves, one P wave, and then the QRS complex, so the other is QRS complex, and then the T wave. So these are the basic wave of ECG. I will explain why P is produced and why QRS is produced, and also why T wave are produced. So let's come to explain these things. I have told you in the previous lecture about the action potential, so you can now easily know these things, that this cell is in the rest situation, and this potential is called rest membrane potential. When a cell is not stimulated, this is not stimulated condition, so there will be no wave in the ECG. In ECG will pointed like a through line, not any going up and not going down. So you can easily say these things. And when a stimulation stimulate this cell, when a stimulus stimulate this cell, so as I told you that the inside of the cell will continue to the positive, and the outside will come to the minus or negative. So you can see these changes in the cell. When a stimulus stimulated this cell is left to go to the other condition called depolarized condition. So when it is in this condition, so it will produce a wave like this, and then when it is completely depolarizing, so this wave will complete it, and it come like this. And then when it is in this condition, this wave is in the first and this is in the second, it means in this condition this wave will produce, and in this condition this wave will be produced. So it means in this condition we will have this like wave like this, and when again it starting going to its normal condition, so it will produce a wave like this first, and when it comes again to this condition, it will complete this wave like this. So you can easily know the that why these waves are producing. It means when a stimulus come to the cells, it produce some charge ion changing in the two side of the cell membrane, and these changes produce voltage differentiation, so it produce a wave like this. So you can easily learn these things. And then as I told you, the cardiac electrical activities, so from where P waves of ECG is producing, from where QRS complex is producing, and also from where the T wave is producing, and how are their shape. I will explain these things in this picture. So first of all, ECG in P wave, when electrical impulses are producing in the SA node. So when it is in the SA node, and then it spread to the atrium. So atrium. So it spread to the atrium. So the depolarization of the atrium produce a wave called P wave. The depolarization of the atrium produce a wave called P wave, you can easily say. So the P wave is from depolarization of atrium. Then this electrical impulses come to the AV node. You can see it in the red color. This electrical impulses come to the AV node. In the AV node, when there we have a time called ventricular activation time. So in this time, when this electrical impulses is in the atrioventricular septum, it produce the first part of QRS complex, the Q wave. QRS complex has three complexed wave, Q, R and S. So the first wave or the Q wave is produced when the electrical impulses in the first part of the atrioventricular in the interventricular septum, in this septum, and then this electrical impulse is coming to the apex or near to the apex of the heart, and it produce the when they are in the middle point of the atrioventricular point, and they are near to the apex, so they produce the first part of you can say it in the gray color, first part of the R wave, and when the electrical impulse is coming to the apex of the heart, so they produce the remaining part of the R wave, and the S wave. You can see it in this point. Remaining part of the R wave in some part of the S wave, and then when the electrical impulse is coming to the again to the base of the heart or to the base of the ventricle, so they produce the remaining part of S wave, and also that then ST segment. All these things are remaining S wave is produced when the electrical impulse is reached to the base of the ventricle. So I hope you will learn something from these lessons. So as a conclusion, I want to conclude these things in this first slide, that I told you that from SA node, when electrical impulses are producing, it go to the atrium first, and they depolarize the atrium, and the wave of the depolarization of the atrium is P wave. And then when the electrical impulses come to the atrioventricular interventricular septum, so they produce another wave called Q wave. And when this electrical impulse is reach the apex of the heart, so it reach the apex of the heart, it produce the R wave. And then when this electrical impulse is coming to the base of the ventricle or base, these points are depolarizing. So in this depolarization they produce the S wave, and then when the repolarization of the ventricle are occurring, so it produce another wave called T wave. So P wave, and this is QRS complex, QRS complex, and this is the T wave. You can easily say that depolarization of atrium produce a wave called P, and depolarization of ventricle produce a complex or three wave QRS complex. In the repolarization of ventricle produce another wave called T wave. But if you have a question that where is the repolarization wave of atrium, so the answer is that the QRS complex or this contraction or depolarization of the ventricle are is so powerful, so they hide the repolarization wave of the atrium. So we can't see the repolarization wave of the atrium in the normal graph, as QRS or the contraction of ventricle is very powerful, so they hide the repolarization wave of the atrium. So thanks for watching. Again, if you did not subscribe to our YouTube channel yet, so please subscribe our YouTube channel, and also don't forget to share it with your friend. Thank you.